Hi everyone, I'm Ingestion and this is my term project submission in B.Sc Honours Data Science and Artificial Intelligence at IIT Guwahati. In this video, I'll walk you through my project, retail sales analysis, customer churn prediction, and sales forecasting. A quick intro before we dive in. I'm a trimester 7 student in the online B.Sc program, and for this term project, I wanted to work on something close to a real business problem, understanding retail transactions well enough to predict customer churn and forecast future sales. Here's what I'll cover: the problem I set out to solve, the tools I used, walkthrough of the dataset and the code, the results from both models, and an honest look at what worked and what didn't. Coming to the problem statement, retail businesses generate a lot of transaction data, but on their own, rows in a spreadsheet don't answer the questions that actually matter. How is revenue spread across the customers and categories? Which customers are at risk of not coming back? And what do sales look like over the next few months? I picked this problem because it touches three different skills at once: database design, machine learning, and deep learning. And because churn and forecasting are genuinely useful problems for any retail businesses, not just an academic exercise. My objectives are straightforward: get the data into a proper database, clean it, explore it, engineer customer level features, predict churn, and forecast sales with an LSTM model. On the data side, I used PostgreSQL with SQL Alchemy to connect from Python. For analysis, I used Pandas, NumPy, Matplotlib, and Seaborn. For the churn model, I used scikit-learn's random forest classifier. And for sales forecasting, I used an LSTM built with TensorFlow and Keras. I developed everything in Jupyter notebooks and tracked the project with Git and GitHub. Coming to the dataset is a retail transactions dataset downloaded from Kaggle. 1,000 transactions, each from different customer, so 1,000 unique customers in total. Each row has a transaction ID, date, customer ID, gender, age, product category, quantity, price per unit, and total amount. Total revenue across the dataset is about 4.56 lakhs, and average order value is 456 rupees. The customer range from 18 to 64 years old. One detail that matters a lot for later, that is, every customer here appears exactly once. There is no repeat purchase history in this dataset. Now I'll walk you through the code. This is the first notebook, setup and DB. This notebook connects to my PostgreSQL database and loads the raw CSV into a table called retail sales. This is the ingestion step, and from here on, everything downstream reads from the database instead of the CSV directly. Coming to the second notebook, EDA and SQL. Here I clean the data, parsing dates, checking for duplicates and nulls, and standardizing column names. Then I explore it transactions by category, sales by product category, and monthly sales trend, and the customer age distribution. I save this as summary tables: category sales summary, monthly sales summary, gender sales summary, and weekly sales summary. So later notebooks and any SQL reporting can just run these directly instead of recomputing them. This notebook also builds customer features, one row per customer with total spend, transaction count, quantity, average order value, and recency in days since their last purchase. Coming to the ML customer churn, this is the churn model. I pull the customer features database, one hot encode gender, scale the numeric features with the standard scaler, and train the model with random forest classifier with 200 trees and max depth of 8 to predict the churn label. I'll walk you through the result in the metrics section because it's actually the most instructive part of the project. Coming to the sales forecasting, I take the monthly sales summary table, scale it with min-max scaler, and convert it into overlapping 3-month window so an LSTM can learn the pattern. The architecture is two LSTM layers, 64 units and then 32 with a dropout in between followed by dense output layer. I train it for 50 epochs and then roll it forward to predict the next 3 periods. Coming to the outputs and results, looking at the EDA first, revenue is fairly evenly split across electronics, clothing, and beauty, all within about 9% of each other, and spending is almost evenly split between male and female customers, so there is no single segment driving the business. Monthly trend shows a peak in May at just over 53,000 and a dip in September to about 23,600. The very last data point, January 2024, is much lower, but that's because it's a partial month at the edge of the dataset, not a real collapse in sales, and it is worth calling out because it directly affects the forecast. For forecasting, the model predicts roughly 34,100, 31,700, and 26,000 for the next 3 periods, which is a declining trend. Given that partial last month feeding into the sequence and only 13 months of data overall, I would treat this as a directional signal rather than a precise prediction. Coming to the evaluation metrics, here's the part I want to be upfront about. The churn classifier reports 100% accuracy on the test set. That sounds great, but it isn't. And I want to explain why because understanding is more valuable than the number itself. Since every customer in this dataset has exactly one transaction, my recency based churn rule ends up labeling the entire customer base as churned. There's only one class in the data, so the model never actually has to discriminate between churned and retained customers. It just predicts one label it's ever seen. The 100% accuracy is a symptom of that single class label, not the evidence of a strong classifier. This is genuinely useful lesson from the project. Churn only means something if customers have a purchase history to measure recency and frequency against. With a dataset where customer shows up once, churn labels have to come from the somewhere other than than that single transaction. Ideally, from real repeat purchase records in a bigger dataset. The forecasting model doesn't have this issue. The LTSM's loss and validation loss both decreased over training. The forecast trend is at least consistent with the actual seasonal dip. I'd still flag that with only 13 months of history, the forecast has a real uncertainty. More historical data would make this much more reliable. To summarize, this project builds a full pipeline, PostgreSQL storage, data cleaning, exploratory data analysis, customer feature engineering, a churn classifier, and an LSTM sales forecaster. The biggest technical takeaway for me was less about the models themselves and more about how much the quality of a label matters. The churn result taught me that a perfect looking metric can hide a real problem and how the label was constructed. If I were to continue this project, I would want a larger real-world data set with an actual repeat customers. The churn labels reflect real behavior instead of a heuristic. I'd also bring in external factors like promotion and seasonality, extend the time series for a more robust forecast, and eventually wrap this into a live dashboard. The full code, notebooks, SQL queries, and report are on my GitHub. Thank you for watching.